Polytechnical University of Bari, and I'll be your session chair for today. We start with the first short research paper, 5 minutes, FairCRS towards user-oriented fairness in conversational recommender system by Qin Liu, Xuan Feng, Tianlong Gu, and Xiaoli Liu. The presenter is Liu Qin.
Hello everyone, I'm Qin Liu. I'm excited to present our work FairCRS toward user-oriented fairness in conversational recommendation systems. It explores innovative ways to mitigate the user unfairness problem arising from unbalanced interaction data in conversational recommendation systems. Conversational recommendation systems, or CRS for short, have become an emerging research topic. It aims to learn user preference and provide recommendations through multi-tone conversations. However, existing CRS models concentrate on the improvement of recommendation performance while ignoring user-oriented fairness. The conversational recommender system consists of a dialogue component and a recommendation component. The dialogue component captures user preference based on the contextual dialogue C, where V denotes a single word embedding and N denotes a single item embedding. The recommendation components generates an ordered recommendation list based on user preference. Despite the significant progress in the recommendation quality of current CRS, data imbalance and user fairness issues still hinder the capture of user preference to generate accurate recommendations. As shown in figure A on the right, a significant long-term phenomenon exists in the user's interaction distribution for the conversational dataset TG readout. This unbalanced interactions data leads to different quantity recommendation results for different user groups. As shown in figure C, the model performs more effectively on the top 5% of users in terms of interaction level, which violates the fairness of user-oriented recommendations. To mitigate the user unfairness problem in CRS while maintaining the overperformance, we propose FairCRS towards user-oriented fairness in CRS. It consists of user-embedding reconstruction and user-oriented fairness strategy. The user-embedding reconstruction mechanism consists of diversity embedding and similarity user embedding. Diversity embedding is helpful in mitigating the performance bias of inactive users, and similarity embedding helps in exploiting the latent preference of users. The user-oriented fairness strategy depends on the following rankings loss function. This loss function introduces a sigmoid function to smooth out the scoring differences, as well as a differentiable logarithmic function. Both are helpful to solve the problem, which is difficult to optimize the traditional ranking-based learning objective. In this paper, we evaluate FairCRS on 2 datasets, and the fairness metric diff is computed as the user group performance difference. In addition, we evaluate the overperformance using the following 3 metrics that are common in recommendation. From the result of the baseline approach, we observe that existing CRS methods exhibit high diff values. This suggests that these measures tend to learn user unfairness from unbalanced historical interactions. Regarding our proposed methods, FairCRS achieves the most fair results. While improving user fairness, our approach maintains the overperformance well. Finally, we conducted further ablation experiments, which shows that each component helps the models to generate more accurate and fair recommendation. We have open sourced our code at GitHub. You can scan the QR code to get it. That's all. Thank you for your attention.